Welcome. This is Sachin Hulagiri. Let's continue our discussion on statistics and data science. Chapter 2, Population and Sampling. Topics covered in this one: population and sample, sampling methods, sampling using R. Population. What is population? The totality of units under consideration is called population or universe. Population which contains finite means countable number of units is called finite population. A population which contains infinite or uncountable number of units is called an infinite population. Sample. The representative units of a population is called a sample. Sample is used as a basis for making estimates and inferences about the population. For example, as shown in the picture, we have fruits filled in a basket. The 3 fruits taken out from the basket is called a sample. Advantages of sample: it reduces the cost, greater speed, greater scope, and desired accuracy. Let's see sampling. What is sampling? It is a procedure or a process of selecting samples from population. Sampling theory. Sampling theory is a study of relationship existing between a population and the samples drawn from the population is called a sampling theory. Statistical inference made on the basis of sampling results. Statistical estimation. It helps in estimating an unknown population parameter on the basis of variable statistic computed from the sample drawn from such a parent population. Means we estimate a population parameter based on the samples drawn. What is parameter here? Any statistical measure computed from population data is called a parameter. For example, mean of a population data is represented as a parameter in statistical terms. Test of significance. It helps in determining whether observed difference between two samples are actually due to chance or whether they really significant, which helps to decide which population is better. Basically, when we draw two samples from the population, we compare the two samples and we can tell which population is better. Statistical inference. This helps us to take a conclusion on a population using sample statistic. What is statistic? Any statistical measure computed from sample data is called a statistic. For example, mean derived from the sample data is called a statistic. Sampling methods. There are different types of sampling methods. Mainly it is categorized into two major categories: probability sampling or random sampling. Another one, non-probability sampling or non-random sampling. Let's see the probability sampling. Probability sampling is further divided into simple or unrestricted random sampling and restricted random sampling. Simple or unrestricted random sampling is further can be derived from lottery method or table of random numbers. Whereas restricted random sampling can be derived from systematic sampling, stratified sampling, or cluster sampling methods. Let's see non-probability random sampling. Non-random sampling. Here we can follow the judgmental sampling, quota sampling, or convenience sampling. Let's see one by one. Probability random sampling. Each individual is chosen entirely by chance, and each member of the population has an equal chance of being included in the sample. Random sampling can be classified into simple or unrestricted random sampling or restricted random sampling. Simple unrestricted random sampling selects the units with the equal probability and with the replacement. Because units are selected with replacement, a unit can be selected for the sample more than one chance. Means here every time a population will be the data selected from the sample will be sent back to a population, and another sample will be drawn. Under this, data can be collected with via lottery method or a table of random numbers. Let's see lottery method. Each of the n population members is assigned to unique number. The numbers are placed in a bowl and thoroughly mixed. Then the blindfolded researcher selects the n numbers from the bowl. Table of random numbers. A random number, a table is a list of numbers composed of digits 0 to 9, and the numbers in the list are arranged so that each digit has no predictable relationship to the digits that preceded with it or to the digits followed it. Means when I select a certain number, the numbers chosen between the digits chosen in the number will not have any relationship. The numbers in the random numbers table are random numbers. Let's see restricted or random sampling. It's also called as a systematic. In that one, it is a systematic sampling. In this method, every elementary unit of population is arranged in order, and the sample units are distributed at equal and regular intervals. Advantage with the systematic random sampling: most suitable for the population units are serially numbered or serially arranged. This saves us time and the cost. Disadvantage with this systematic sampling: there is a chance of losing a vital information from the population. It may not be good for periodic data, as we select from particular things, so it may not be good for periodic data. Let's see restricted random sampling. It's also in that one stratified sampling. Here the population is divided into non-overlapping subpopulations called as strata. The researcher then extracts the random sample from each of the subportions. Means the whole population is divided into exclusive subportions that we call it as a strata. In that one, researcher will extract a random sample from each of the subportions. That is called a stratified sampling. Advantage with this one is it is a representative sample of the heterogeneous population. It minimizes the probability of bias if one-sidedness. Disadvantage with the stratified sampling is difficult to divide the population into heterogeneous groups. It is costlier than simple random sample. So let's see the cluster sampling. It involves in arranging elementary items in a population in a heterogeneous subgroups that are representative of overall population. Advantage of cluster sampling is this sampling technique is cost effective, quick and easy. Disadvantage of this cluster sampling is when the elements of a cluster sampling are same, Sampling from the cluster may also be no better than the sampling in a single unit from the cluster. Let's see the non-probability random sampling. A core characteristic of a non-probability sampling technique is that samples are selected on the subjective judgment of the researcher rather than the random selection, which is a cornerstone of a probability sampling techniques. Non-probability random sampling has three types: judgmental sampling, quota sampling, convenience or accidental sampling. Let's see one by one. Judgmental sampling. Judgmental sampling is a non-probability sampling technique where the researcher selects the units to be sampled based on their knowledge and professional judgment. This type of sampling technique is also known as a purposive sampling and authoritative sampling. Non-probability sampling in that one, let's see the quota sampling. Quota sampling is a non-probability sampling technique in wherein assembled sample data has the same portions of individuals as the entire population with respect to known characteristics, traits or focused phenomenon. Here the researcher must make sure that the composition of a final sample to be used in the study of meets that research's quota criteria. Based on the quota criteria, researchers will select the sampling here. Convenience sampling, or it's also called as the accidental sampling. A convenience sample is made up of people who are easy to reach. Consider example student volunteers as a subjects for the research. So let's see the how we can derive a sample from the in R using population. Let us take a S1 is a data set which is being loaded with a sequence of numbers 1 to 20, and let's generate a random sample from using a command sample S1, and 10 is the number of values we are drawing from the population. Here population is 1 to 20 and we are drawing 10 elements from the population S1. When we take a random sampling, it will give the random numbers, and let's see one more time draw the same command 10 numbers of the sample. See if we can observe here the number of values are different. Let's see the sample with the replacement. Here the sample item will be considered again in the next iteration of sampling. Here you may find repeated values in a sample. The command executed is sample S1, the number of sample size 10, and replacement is equal to true. When I say replacement is true, first we can find a number of values repeated here. For example, first it will draw the 14 from the 1 to 20, and the second time it will draw 11 from 1 to 20, and again third time there is a chance of 1 to 20 is coming. So you will find the repeated numbers here. In the first command you are able to see 11 is repeated, and in the second set 14 is repeated. Sample without replacement. Here sampled item will not be considered again in the next iteration of sampling. Here you may not see repeated values unless the population has a repeated values. In our case 1 to 20 it has a unique numbers. When I draw a sample of 10 units with replacement as a false, you will not find any repeated values as we are observed in the above example where 11 and 14 are repeated. This concludes the topic on sampling, population sampling. Please write me on sachin.hulagiri99@gmail.com. Thank you very much.